Folks, good morning. Thank you for coming out. Welcome to the session, Defending of the Land. I'm Mark. This is my colleague, Jacob, and we're from Thinkst. We're going to be talking Defending of the Land today. We're a security product company. We're founded on the back of our in the trenches pen testing experience. Jacob runs labs and I run the engineering side. In fact, though our names are on the slide, on the title slide, several other team members have also contributed towards this talk in various ways. Collaboration is how we build the talk. It's also how we build tools that help defenders win. We've also relied on several open source projects. We'll call them out as we get to those slides. We've got a bunch of content to get through today. So this is the broad outline. We're going to look at the background and our context for Defending of the Land. We're then going to introduce and go through 11 plus 1 techniques. For some of them are new, some of them are a new twist on older ideas. And after that, we'll hit the last few slides. Before we get there, let's tackle that main question that no doubt is brewing in your minds already. I'm saying Defending of the Land, why should you care? And it's a question you should always ask, of course. And here's the bottom line. We're going to be showing you 11 plus 1 techniques that are going to help detect threat actors without installing any additional software. Right? And so this talk is for folks who protect networks. It's for sysadmins worrying about the gaps in their networks where EDR can't or won't provide visibility. Before we get there, let's look at some of the background to this work because it's going to explain how we got into it and what led up to it. We make tools that help defenders win. Most of them are free. We make Canary tokens, and on canarytokens.org, millions of tokens have been minted. We put out Open Canary, which is our open source honeypot deployed around the world. Our labs team, headed by Jacob, puts out research every quarter, and they spend many hours summarizing, reviewing, and publishing these research summaries. And that's all on the free side. The commercial side is we've got some commercial honeypot and Canary token stuff. We've been doing deception for a decade now. And in fact, in 2015, we put out a talk at Black Hat USA entitled Bring Back the Honeypots. And that talk introduced Open Canary. It introduced Canary tokens. And Canary tokens specifically was this novel twist on the older honey tokens idea. We liked that idea, and 2 years later, in 2017, we put out another talk which really expanded on this idea of Canary tokens. And we've spent the time since then building on tokens, building on honeypot technology. The point is we've been immersed in this now for almost, or actually more than a decade. And so we've got thoughts on the usefulness and design of deception products. For one, we think it's a chronically underutilized technique for detecting breaches. Honeypots, they're the original deception technique that we know about. It's a decades-old idea at this point. We think they're super useful for detecting breaches when they're installed internally. And something to note about honeypots is that they are parallel or adjacent infrastructure. You don't install honeypot software on your production systems. You have your production systems, the honeypot sits next to it. And that's great for detecting lateral movement through your network, attackers moving from one system to the other. But what can you do when the attacker directly compromises the asset that they're interested in? There is no lateral movement. How do you detect them in that instance? And that took us directly into Canary tokens, rather, because these are intended to be deployed on your production systems, but with minimal risk, because Canary tokens don't run any actual code. Instead, what they do is they're going to trigger some sort of network traffic, maybe a web query, maybe a DNS query, some other network packet. And there's a good chance some of you have heard of Canary tokens, but if you haven't, I will give you a short example to explain it. We think of them as little bits of data or information or configuration files that when you put these on an endpoint and an attacker discovers them, they use them in their expected way, and that causes one of these network signals. So I'm going to give you an example here. One of the popular ones is a decoy Microsoft Word document. And the way it works is pretty straightforward. You go to canarytokens.org, you give us an email address, you give us a little reminder of where you put this particular file. We're going to let you download a Word document, and that Word document is going to be a unique Word document, only you would get. And you then put it on, say, your desktop folder, and you give it a juicy sounding name like journal.docx or passwords.docx, right? And you leave it there. You know what that thing is. You're not going to touch it. But if that machine is ever breached and an attacker breaks in, they go looking around for things that look interesting. If they find passwords.docx, of course, they're going to open it. And inside that file is a web bug. It's going to call back to us. We see that, and we send you an alert. Simple idea. It's been out there for a decade. Right, but we think of Canary tokens as a much broader idea than just web bugs in Word documents. This definition that we've got is purposefully broad. On the left-hand side there, we've got what we call the AWS API key Canary token. and we give you valid AWS API credentials. That's 5 lines of text. You put 5 lines of text on an asset. It could be a server, it could be the environment variables for a Lambda, for example. But if that resource is ever breached and an attacker's poking around, they find these credentials, they're going to try them. Those are defang credentials. They belong to an account that we control. We're monitoring the logs. When we see activity on those credentials, we send you an alert. Super simple idea. Or what about a Canary token mobile phone app, right? That app on the phone there says PayPal, but it's not PayPal. That's a simple bookmark with an icon, right? And if that app is tapped and opened, we'll see it, we'll send you an alert. The point is we can give you this detection mechanism, but without installing anything. That's not an installation of software, that's simply creating a bookmark. And so this idea of Canary tokens is one that we've been working on for quite a while. The issue in terms of detecting breaches is that time and time again, as defenders, we want to install tools that we think are going to catch attackers, but the tools often are not thinking about where the attackers are. They have this sort of wish casting or normative idea of what attackers should do instead of what attackers actually are doing. But we need to find ways to get in front of the attackers, not put them in front of us. We've seen some missteps in some sense in the security industry. Early IPS was an example of this. We thought that we could just run grep across all of our network traffic, and it turns out that as much as we wanted that to work, it didn't work. Scale was one reason. As soon as we started encrypting all internal traffic, grep also became useless in this example. And so we wanted IPS to work, but it was not getting in front of attackers. Another example for this is seams, and so this is a very unscientific poll on X, formerly known as Twitter, but a well-known seam analyst asked the question, folks who have seams, did it ever catch at least one attack? And like 50% of the respondents said it hasn't caught an attack. Now, seams are not for the small, the shy, or the skint. They're really going to be in organizations that typically will be targeted, and only half of them have even caught a single incident, right? So seams, their value is somewhat questionable. I'll do a quick shout out there. Somebody thought that there was a product that did work, but I'll say no more about that. In thinking about breach detection, EDR seems like the obvious solution here, and we're not knocking EDR. We think EDR has an important role to play. But malicious actors expect EDR, and they do work to bypass EDR. And not only that, we know that EDR can't be installed in many locations. Maybe those assets are too old, maybe they're too weird, or maybe they don't actually belong to you. The point is you can't get EDR across your fleet. And so in that instance, how can we start implementing detections? Well, let's take a leaf out of the book of threat actors, where they go, when we're presented with a bunch of constraints, how do we work around them? And it's easy to think of attackers as this genius level strategist when they're confronted by challenges where they're always trying to play 4D chess and targeting only those systems with national security importance, or they're genius level vulnerability finders and exploit writers who they can always uncover brand new exploits. But sometimes they're not looking for a better mousetrap. Sometimes they're really just happy to reach for those tools that are there. And we call that living off the land, right, for attackers. Now, since 2015, there's been this public rise in the idea of attackers living off the land. The first talk that we know of, and we track talks, is in 2013. And in 2015, there did seem to be a shift because Windows 10 was released in 2015. It came with this vastly increased set of capabilities that attackers could use, but it also limited attackers in terms of running untrusted binaries. And so we saw more research into this idea of living off the land, because it means using those capabilities of the legitimate tools already built into the system instead of the attackers having to carry their own tools onto that. And they realized there are a bunch of benefits there, right? They didn't have to worry about DLL hells or version dependencies or language pack support. They didn't have to worry so much about the idea of being discovered because they're not running mimikatz.exe. They can run tools that blend in with regular sysadmin behavior. And they also had less chance of being attributed because they're not deploying custom implants. These are, again, off-the-shelf tools. So I do want to take a quick look at a few of these techniques because we are going to call back to this. One common attacker living off the land technique is the idea of, instead of read or writing custom network traffic redirection, you can just use Windows built-in NetSH port proxy. Instead of building fancy persistence, you can just use scheduled tasks, right? And let Windows worry about the problem of leap days and leap seconds, which it turns out may turn negative shortly. Instead of worrying about building DLL loaders and trying to figure out how to parse PE files, you could just use rundll32.exe. And when it comes to privilege escalation, instead of an attacker having to find some novel vulnerability, kernel level vulnerability, just bring along a vulnerable driver that's already signed, that will be loaded, and you've got an off-the-shelf exploit. You know these techniques. There's nothing new in what I'm saying there around those techniques. And at this point, you're probably thinking, this is a talk about defending. Why are we talking about attackers? Well, living off the land largely works because the attacker's goals run, if not directly parallel, well, at least in the same rough direction as that of regular sysadmin tasks. And for threat actors, those sysadmin tools are often enough to get by without needing to install additional tools. Let she who has never added no password to a sudoers file or set all permissions on a file system or granted admin on a GitHub repo to help a developer get past some obstacle, cast the first stone. Those are sysadmin tasks, but they are also the sorts of things that attackers might do for persistence. And we think defenders can learn lots from attackers in this regard of reusing the capabilities already present on your systems. And that's the essence of what we're saying with defending off the land. We love flipping the script on attackers and using their techniques against them at things. With deception, we think there's lots of scope for subverting those attackers' expectations. We can learn from attackers living off the land and build deceptive detections using the functionality and tools already present. So we think it's about leveraging the capabilities already there. It gives us this defensive tooling without needing to install additional software. It might require some scripting from time to time, again, like any decent sysadmin would. And we're going to be laying traps, and we're not going to be installing additional software to detect the attackers. As we mentioned earlier, a big driver for this is the idea that EDR doesn't give you 100% visibility. We can't get EDR across every asset in our estate, and these sorts of techniques become options for when we can't. Now, a legit question you might be thinking is any of this actually new? And arguably, the concept isn't new, right? Clever sysadmins have been doing this forever, laying environment-specific traps. A couple of years ago, there was this idea that you could install Cyrillic keyboards on your endpoints because Russian malware, when it saw that, or certain Russian malware, when it saw the presence of Cyrillic keyboards, would just exit because it didn't want to target Russian systems, right? And so that's not installing any software to defend those systems. You're making a config change, and that's part of this defending off the land. But we want to be clear, we think this is deeply rooted in the idea of sysadmins doing their job, and we do think it deserves this label, defending off the land. It can also be combined with deception, moving deception not just from the network, but into the OS itself, presenting threat actors with fake but juicy looking files, config data, or commands. If this sounds like work, yes, we're saying it's work. Like, this is not a product class that is going to save you. And by definition, we're giving you techniques, not an entire new product. We're also only focusing on Windows in this talk. We think that there's scope in other platforms, but for this one, we're only hitting Windows. And in terms of where we get our ideas from, John Lambert said it best 10 years ago, defense is led by offense. We have to look and see what the attackers are doing if we want to get in front of them. And so for this, we're reading the DFIR reports, we are reading papers that we collect at citation.thinks.com, and we're looking for those visibility gaps. So with that, the background is done. It's going to be time to dive into the techniques. This is an overview of where we're going to go with this. We're going to talk about some of the primitives that we use throughout the techniques. We're then going to look at ways to detect local threat actors. We're then going to look at ways to detect remote threat actors, and we're going to finish off with a cloud technique. And with that, I'm going to hand over to Jacob.
Thank you, Mark. Just like attackers living off the land, defenders have to examine the raw materials available to them, so to speak. The next few slides, we're going to look at a few exemplar primitives that we're going to be using time and time again in some of our specific capabilities. And then you can kind of see this as the raw materials that you're able to manipulate or tweak to your environment. So we're going to start off just for context with the kind of popular Canary tokens on canarytokens.org, which is where we give you either a web bug, so a URL, or a custom domain name. And if those are ever accessed or resolved, we send you an email or we fire off a webhook. And since this is such an easy way, you can pretty easily resolve a domain name from PowerShell or from Bash, it's an easy way to get that alert off of that system and back to where you can action off of it. We do want to note that there is kind of a balance between the two. So HTTP request, the client is directly connecting to our server. They can put arbitrary data in that request. So we get the IP address, we get whatever other information we can contextualize that with. DNS, you only get the IP address of kind of the resolving DNS server. You don't get to put extra information in there usually, but it works even in highly restricted environments. You don't need to worry about what your proxy settings are or what your firewall or WAF rules are. So our Canary product actually uses DNS to communicate with our servers so that you never need to muck with that. And so if you can resolve a host name in your network, you can get this alert out. And so we use that kind of interchangeably depending on your environment you're going to put these in. That can kind of be the trade space you're going to evaluate. So with that context in mind, we're going to move to our first primitive that is more specific to defending off the land, and that's the Windows Crypto API. So within that Crypto API, there's this field that is accessed called the Authority Information Access field, or the AIA. And that's a URL that when you're using TLS kind of how you're supposed to, rather than shipping the entire chain of certificates, you just point a URL to the kind of issuing certificate authority and you can kind of go up that way. And so if your client has already seen that CA, they don't need to go and waste this bandwidth. What's really cute is you can just shove a Canary token URL in there, and then when that certificate is validated on the endpoint, it goes and reaches out for Canary tokens, and then that triggers the alert. And so we'll see that this is a primitive we use for a couple of our tokens to get information on the attacker side. On the endpoint itself, PowerShell has become a very powerful first-class language in Windows for all types of sysadmin tasks and beyond. It does have this other feature that I do want to highlight, the add type feature, which allows you to dynamically generate a string of C# or other .NET code, which gives you full access to the Win32 or the .NET APIs, and then you just invoke that string as an instantiated object. So without having to worry about compiling to libraries, shipping out, making sure you have the right .NET, this is all built in. You don't need Visual Studio. You can just write some C# and say, I want to run that C# within the context of PowerShell. And so this is a very powerful primitive to access those lower level system APIs from a nice high-level scripting language. And so now that we have that primitive to run a lot of interesting things on the endpoint, how do we trigger that? How do we kind of see when badness is occurring? And that's where we use a lot of Windows events, and then you can actually trigger off of specific events. So there's thousands of events out there that Windows is tracking, and you can create things that happen when those events are seen. Many of them need to be enabled either through some registry change or configuration change, but once that's enabled, then you have a really good way to kind of say, this is the condition I'm looking for, and now I want to run some action. And then finally, to get that alert to the defender, you'll see some of our demo videos. It's a lot easier to show a little pop-up or a little toast in the notification bar, so you'll see that pop up. And that's kind of handy if you are, for example, on your laptop in a coffee shop and someone is browsing your Canary file share. You get a little note, hey, someone just tried to open your files on your computer. CanaryTokens.org we're going to use as well, using that easy DNS resolution or web lookup to be able to get that alert off the system. So you may not be sitting in front of your computer at all hours of the day. And so this is a nice way where it buzzes your phone saying, hey, someone's on my computer. I should go check that out. And it's really important to remember that these are just the primitives we're talking about right now. And you'll see them put into specific capabilities, but in a way that you can go in and change them out. It's just kind of an exemplar, an illustrative capability to show the power of these primitives. So with that out of the way, let's look at these 11+1 Canary tokens that we've built. Some of these are now live as of the last day or so on canarytokens.org. You can go check them out. You can play with them. Others are either not quite mature enough or don't have that simple set it and forget it. Maybe they require kind of a more nuanced deployment that ties closer to your environment or has other types of kind of, little bit more configuration that might be needed. And so in those ones, they may not make the bar for canarytokens.org, but everything will be released open source in a Defending Off the Land repo that we put up. And the slides are going to have either an Octocat GitHub logo if it's on the repo or a Canary Tokens logo if you can go and play with it right now. So we're going to run through these pretty quickly because we do have 11 plus one of them. Some of them are pretty similar or they use the same primitive, so I'll spend a little bit more time talking about the first one and then the subsequent ones. I hope you just get the idea, kind of show a demo, and then we'll move on. All of our slides are going to be published with links and everything, so don't worry about taking notes or getting a picture of each one. You'll be able to grab all this off the internet later. So now we're going to start with capabilities that detect badness on your local system. I personally run a few of these because EDR on my home environment is a little bit overkill, and these provide really powerful capabilities that help me know, okay, maybe something's going awry. So we're going to start with the sensitive command token, and this was actually the impetus, at least in my mind, to think about this concept of defending off the land. So we released this last year. This one is not brand new. Essentially, it's a registry key that configures the Windows debugging system to run a process whenever another process is run or a command is run. And when we were reading these DFIR reports, we saw time and time again that attackers or malware would land on a system, and then it would orient itself to figure out where am I in this network by running commands that I'm not a Windows guy, but I'd never heard of, right? So they run who am I to figure out where they are. They run tools like Klist, which dump a bunch of Kerberos tickets, for AD authentication, or NL test. And so thinking these are very rarely run benignly. It would be really nice to know, hey, someone in your organization is running these commands. And so real quick, you import this registry file. And if that command, in this case NL test, is ever run, it dynamically encodes the Canary token, the username, and the computer name into that DNS resolution. And so you can put this one registry key and you can push it out across your whole fleet with SCCM or GPO or any other kind of management system. And then anytime someone runs with this command in your fleet, you get an alert saying, hey, Casey on Casey's desktop just ran this bad command. Another cute trick, I know we're talking about living off the land, is you can actually flag executables that don't exist or shouldn't exist. So if an attacker does ship mimikatz.exe over and then they run it, if they haven't changed the name, you get the alert anyways. And so it's kind of a nice way to think about this as a point on this spectrum of defending off the land. And again, now the attacker is met where they are on this endpoint that they are, and it really helps you pinpoint that in your organization and act very quickly before they get super entrenched. So we're going to move to another favorite for offensive living off the land, scheduled tasks. You remember seeing that, this stack of using scheduled tasks for persistence. They are a very popular persistence technique. It's well documented online. If you just search scheduled tasks living off the land, you'll get a whole bunch of tutorials for how to do this. And you can use it to run your malware, reverse shells, whatnot. And so for this capability, we created ourselves a scheduled task that is triggered by the creation of scheduled tasks and then evaluates what this new task is doing to see, is this a normal system behavior or is this running PowerShell, CMD, something suspicious like run DLL. So to sum it up, it is very much like this. Yo, dog, I heard you like scheduled tasks, so I made a scheduled task to look for new scheduled tasks. So real quickly, jokes aside, this quick demo shows me as an admin now creating a scheduled task. So this is post-exploitation. I'm running this new task that says command.exe, and you'll notice this little toast pops up that says, this task is suspicious, and you should go check that out. And so very simple thing, very simple capability, but gives you visibility, and this can obviously all go out to canarytokens.org as well if you want to get this remotely. So moving to another hotspot of malicious activity, the registry. So the registry in Windows is used for a host of attacker living off the land reasons. You can either weaken the system, so you can open up more ports, you can disable firewall rules, or you can just get persistence both on disk and off disk. And so this capability we built is a very simple PowerShell script that runs periodically and looks for changes to the specific registry keys that attackers love to manipulate. And so we have about 80 keys that are used in this attacker living off the land. If any of those start to change, we let you know. And so you'll see here, super simple. If I change the startup folders, this one that maybe has some payload on there, as soon as I save that, within a few seconds, you're going to get both an email alert saying these keys have changed, or you get the little pop-up toast saying, hey, this key has changed, you should go check that out. Again, very straightforward, very simple, but it helps us catch people who are trying to live off the land. Next, we have another very popular post-exploitation target, the Windows Service Directory. So if you look at malware campaign analyses, very commonly, once they land on a system, they disable either defensive software, or if it's ransomware, they disable backup services and other types of things. Because if they are going to bring something, a unique payload or new capability, they don't want to have to worry about Defender or some of these other services. And so basically what we were able to do is, building off some work from JF Slaviero, we can build in PowerShell a Windows service that registers, and it by default looks like Malwarebytes anti-malware. And if that service is ever manually stopped or stopped from the command line, it triggers an alert. So very simple. If someone is in there trying to make themselves comfortable in your environment and they stop it, you get an alert. It's very simple to understand. You'll see here there's the Malwarebytes anti-malware system. I click stop. And then you'll notice that when I refresh the Canary tokens, you'll see that it has caught that, and now they've alerted us that they're on that system. This is the service they've stopped. So very straightforward. So the next two capabilities are for monitoring file access. So we're going to spend a little bit more time on the first one. The subsystem is more complicated and I think is underappreciated. And then the second one is a different way to get to the same thing. So we really wanted to nail this capability where you can have a folder tree either on a server or on an endpoint where you know not to go in there and poke around, but it might look really juicy. So if someone is on that server and they go into any file and they open any file under that root, you get an alert. So we spent a lot of time looking at the different kind of living off the land primitives for this. Projected file system is the one we ended up chose on the top, but we also looked at file system watchers, object auditing, and controlled folder access. And for us, ProjFS, despite being not very well known, is a pretty powerful primitive. And so you can think of ProjFS, or projected file system, as essentially Fuse for Windows. So it's a user space API where you can project files essentially out of thin air. And then Windows itself will handle the messy filter driver handling. And so if your code crashes, you don't blue screen the box, just those files from the root just kind of disappear until you reload. What's really cool about this is that you can run it in C#, PowerShell, even Python. And so you can use it to create, essentially a mythical file system. It's used by Microsoft to browse Git repositories, so you can switch branches and then the files all change. And also they have a demo of projecting the registry from regedit into Explorer, so you can browse into your trees that way. It's been used in the past by others to look at tar pits. So basically creating file systems that malware gets stuck into. And we verified that actually. It's pretty fun. If you return a byte at a time of a file, it really does slow down ransomware. Or if you say, oh, I'm busy right now, and here's the first of 3,000 files in this directory, come back to me in a few seconds. It really does kind of muck up the works. And so it's pretty complicated, but we made it really straightforward. You go to canarytokens.org, you click it, you give an email address, you kind of select what kind of files you want. You can choose from our ChatGPT generated file structures, for your personal finance, your home network, whatnot. It just generates a CSV. You can edit that yourself. And then you run this and it'll be projected. So now it looks like those files really exist. And if you go in, regardless of how you go in there and try to look at them, you get the alert saying, hey, PowerShell just opened up this file, go check that out. And so this right here, you'll notice is on canarytokens.org, but we went one step beyond this, which was something we thought maybe was a little bit more risky, but maybe more fun, especially if you're doing it, cognizant of that. And so this is on our open source repository. It automatically will also create a file share. So it makes it look like you've been sharing your personal documents open to everyone. And so if you're at a co-working space or you're at a coffee shop, you can see if there are people perhaps a little bit more snoopy than they should be. And so we wanted to make sure this worked before we released it. And so we did find actually it works really well with Windows search indexing and like defensive tools. They kind of just run through it and it doesn't cause any problem. We get the process that's triggering the alert. And so we can kind of ignore certain processes, or we can flag or behave differently depending. So we can say, that's not Explorer. Let's make a 3-second wait. And then we did run both the stand-in for ransomware, so fransom, and so that's how we evaluated this tar pit idea, as well as Snaffler, which is a red team tool that looks for credentials, passwords, other kind of sensitive data on a system, and helps attackers kind of collate that to then figure out where they're going to go next. So we think it's a very powerful capability. We're really excited about it, but it is heavyweight in the sense that you are kind of deploying this script and turning on this subsystem. So it might be something a little bit more than what you'd want to deploy at scale. And so for that, we built the network mount token. So it's very similar capability, but a heck of a lot simpler. Basically, we host a network drive, and we provide credentials, unique credentials for that network drive. Again, you can choose the ChatGPT generated file structure you want, and then you mount that using WebDAV or to your network drives. And if an attacker lands on that system, they're probably going to be curious to see what's in z:corp. So we wrote this all as a Cloudflare worker, so it's very scalable, very fast, and it runs globally. And again, if any of the contents of that file is ever accessed, you get the alert. And I know Marco did say that this was a Windows-specific talk, but there is WebDAV connectors both on Mac OS and in Linux, so this is a cool cross-platform capability. It's very straightforward. So on this computer right here, there's a pretty juicy looking network mount called Corp IT, and it's got some stuff in there that maybe an attacker might want to look, and if they open any of those files, bam, I get an alert. So now we're going to move from the local access and the local attacker techniques to ones that are going to catch remote attackers, and starting with remote desktop or RDP. So Windows ships built in with Windows Remote Desktop or RDP, both as a client, which is pretty commonly used on endpoints, as well as a server. And it's a very popular lateral movement technique, both for sysads, admins, and threat actors, right? This is an easy way to get around in your network. And so we basically created a simple script that creates a token certificate using that AIA trick I talked about before. And it installs that as the server certificate on whichever system you're tokening. You can optionally then just deny all access to RDP sessions. So even if an admin or an attacker gets admin credentials, you haven't weakened your system. They'll go log in, it'll trip the token, and it will say, sorry, you're not permitted to access an RDP session. Or you can leave it on if you actually want to RDP in for some legitimate reason. And when an attacker tries to RDP to that token system, their client will validate the TLS cert because that's just what they do. And then they trigger it from the attacker's machine. So we get the attacker IP, we get the attacker information from that side because they're the ones that reached out to canarytokens.org looking for that root certificate. So here's a really quick demo. On the left is the defended system. On the right is the attacker one. So I'm logging in with valid credentials as Savvy Defender. And you'll notice that when I click OK, it's going to pop up something and saying, this is a suspicious certificate. Even if they say no and they get wary, it's already tried to validate at that point, and it's already tripped our alert. And so even if the attacker starts thinking, this is really weird, and backs out, it's too late. Even if an attacker is trying to be more circumspect, so they're trying to use like certutil or some of the tools built in that aren't necessarily, using RDP directly, those use the crypto API and those trip the token too. So we were trying to find a clever way. I mean, maybe if you bring it off onto Linux or whatnot, you might be able to analyze it. But yeah, pretty much touching that certificate from Windows will cause the lookup and trip the alert. Another popular living off the land as an attacker is WinRM or PS remoting, PS exec. And these management tools empower you to run your PowerShell or your commands kind of across a larger organization, but it's also very common for attackers to use to move laterally through a network. And so this token script, almost exactly the same. It generates one of those token TLS certs. It sets it as the certificate that's offered for the WinRM HTTPS service, and then it opens it up, but actually denies any actual commands to be executed. So it does the TLS handshake, the token triggers, and then it says, sorry, you don't have permission to do that, even as a local admin or a global admin. And so just like in that RDP token, left side is the defended system, me trying to run a command on the right, it says the certificate is invalid, but it doesn't actually run, and immediately you'll see I've got the attacker's IP address and see that they were coming in over WinRM. So now I'm going to hand it back over to Marco to finish the last few capabilities.
Excellent. So for this next one, we're going to be talking about another way to detect lateral movement. And this time we're going to say, run a local honeypot on every endpoint. Now, I say that, and you're going to be thinking, hey, that's cheating because you told me I don't have to install any additional software. How am I going to run an additional honeypot? And I am going to cheat a little bit here, but I'm not going to say install software. I'm going to say run a VM. And I think I'm going to argue there's a slight difference there. Because here's the beautiful thing. Windows 11 for certain versions comes built in with Hyper-V by default. And we can leverage this thing. We can take this window, we can take Hyper-V and run a VM there, which is not going to pose any risk now to the actual host itself. And so we give you a Hyper-V VM, which is, and inside it is Open Canary, our open source honeypot. We actually give you a PowerShell script as well, which is on the repo, which will manage this VM for you. It's going to set up the network rules, which I'll talk about, and it's going to manage the alerts as well. Now, I'm calling back here to our slide on living off the land with NetSH, and that's because attackers can use it, defenders can also use it to redirect traffic. We're going to be redirecting traffic that's coming into the Windows host, pushing it forward to the honeypot. Attackers think that they're trying to break into the Windows host, but actually what they're hitting is the honeypot that is running under Hyper-V. We also had to build in bidirectional communication between the VM and the host so that we could show the alerts and push the events into the Windows event log. So this is what it looks like. We've got a config file here. I'm just doing some Open Canary configuration. If you can't see the file, that's a bit of JSON. It just says which services need to run. We're then going to tell the host which ports to forward from the host into the VM. And so this is some basic setup. We're then going to run a PowerShell script here, which is going to run the VM, set up that network traffic forwarding, and it's going to also start listening for the alerts. And at this point, off screen, I'm trying to now, as an attacker, SSH into this Windows host. I'm just picking SSH as one of the services. That traffic gets forwarded into the honeypot. The honeypot sees it, but it sends the alert out to the Windows host. The Windows host shows you the little toast there. But of course, if you're not at your desktop at that time, you might miss it. And so it also gets pushed into the event log. So you can come back at a later time and find it in the event log. The next technique that we're going to talk about is this idea that attackers, one of the things that they do on an estate is they're going to be looking for credentials that they can find around the network. And the question becomes, well, how can we detect that sort of activity? And we give you this AD login token, and the idea is quite straightforward. Again, lots of these techniques are sysadmin techniques. On every endpoint, drop a text file with a unique username in that text file, so one unique username per endpoint. And then basically we give you another living off the land technique that scheduled task. Let's have a scheduled task just comb through our event logs looking for these names. It's a straightforward technique, but it's the sort of thing that you can get to with a bit of scripting and no additional software installation. And so in this case, that one, and we've given you a PowerShell script which will set up the scheduled task for you. It's also tied into Canary token, so you can get an email or a webhook. We've handled the alerting for you. The last one that I want to talk about is this threat actor compromise or detection rather up in the cloud. So not local or remote, but up in the cloud. And for this one, it's a departure from the previous ones because instead of trying to detect the compromise of a machine or an asset, we're trying to detect here the compromise of an identity. You know, they say identity is the new X. And in this case, it could be via credential theft, cookie theft, it doesn't matter. You have an Okta, you have an Entra ID. Attackers love to breach those systems because obviously they get access to whatever those users have access to. And so as network protectors, we want to know when those systems have been compromised. This token gives you that ability. And the way that we're going to do it is we're going to give you the ability to deploy a fake app panel on your cloud SSO provider. And in order to do that, we're going to be talking SAML. SAML, if you know a little bit about SAML, they're going to be the IDP. We have to implement the relying party aspect of SAML. CanaryTokens.org today is a SAML reliant party. So you can go to tokens.org, select which fake app you want to deploy into your SSO. We're going to give you the SAML the entity IDs and the URLs and that sort of stuff. You set it up in your Okta, your Entra ID, your one login, whatever your provider is. And so when an attacker actually breaches the system, what they see is something like that. One of those is a fake app, right? The attacker doesn't know which one they breach. They're going to be clicking through those to just see what sort of access they have. They're going to hit that SAP panel. That's going to call through to canarytokens.org. You're going to get an alert. So that takes us to the end of these techniques that we've shown. We've covered them in terms of what sort of attackers that they can uncover, but it's also possible to view them in terms of their intrusiveness to deploy. We kind of give you a qualitative scale there from the most easy to deploy to the ones that require the most intrusiveness, like deploying a VM. But the point is you've got a wide range of options here depending on your appetite. We want to touch a little bit on the sort of directions that didn't pan out for us. And so we explored the Windows sandbox, but in the end, we didn't find it was going to work. The startup times were too high. We also dived into Windows DP API, but in the end, we felt it wasn't up to the task of being a Canary token as we envisioned them. And of course, there's always going to be some caveats to this kind of work. PowerShell, we rely heavily on it. If it's restricted or heavily restricted, it's not going to be as useful here. We do note that some of these audit log events that we enable can affect log retention. And the one that's, I guess, most notable here is we do rely on system behaviors that sometimes can change under your feet. So like Jacob found that Adobe changed their reading of that AIA field in certificates. And so if they change that under your feet, then that technique obviously falls away. These are techniques to use. We also found desktop.ini got the way that Windows basically handled that file changed in the last several years, which affected some of our tokens. And most of these capabilities do have some fingerprints that attackers can look for. We don't deny it. But our point there is that they're not looking for that stuff. And if you can get attackers to the point where they actually are scared and worried and are looking for things, you're already slowing them down. You've already impacted them there. So future directions here. We think that there are more primitives to be explored. We haven't touched any of that stuff on the right. Well, we've touched some of those things on the right, but there's a bunch of things we haven't yet looked at. There's lots of options there. So to wrap up our talk, these are the takeaways. We introduced this idea of defending off the land as a concept, this repurposing of the built-in OS functionality. We've showed you 11 plus 1 techniques. A few you might have seen before, but there should be several novel ones in there. 4 of them are immediately available on tokens.org. 7 of them are up on our GitHub, and that stuff's all live right now. And lastly, defending off the land. It's an inherently active defense. It takes empowered and motivated sysadmins. Celebrate them, let them do their thing. Thank you very much. We're not going to have time for questions, but of course we're here and we'll be in the hallway. Thank you.